Hello, everybody, and welcome to another Microsoft Reactor live stream. It's great to have you. It's another great day. It's another great episode. And today I'm actually joined here with Carlotta again. So I'm going to add you up to the screen. Say hello.
Hi everyone. Hi Liam, how are you?
Yeah, amazing. It's great to have you on here. Thank you for joining again. So what are we doing today? It's going to be episode 2 of a 3-part series, isn't it? So
yeah, exactly.
We throw up the screen, the slides here. So welcome. Today, we're going to be getting practical with ML.NET. And this is episode number 2 of the 3-part series. And we're going to be talking about text classification with Model Builder. So if you joined the last episode, then you would have seen Carlotta and I go through a series of prerequisites for Visual Studio, the Model Builder extension, explaining how to get that on your machine, whether you're on Windows or Mac OS, and different ways around it. So today we're actually going to be getting hands-on, or say Carlotta's going to be getting hands-on for us. So we're going to talk through a little bit of theory first, like we always do. So if I can get the next slide, please. Oh, it's not going to do it for me. I think I have, there we go. Right. All right, hold on, everybody. Technical difficulties straight away. Yeah. It's always good fun when you have PowerPoints, right? And they don't load. So I've loaded up my laptop today, and we have got a whole bunch of things on here. So give this a second for these slides.
It's the good thing of going live, right?
I know, right? There's the demo demons. Okay, let's try that again, shall we? We're going to go into this one. There we go. We have got the next slide. Okay, so like always, we always run the code of conduct. So please take a moment to read this and try and understand it. Just pick out the blue bullet points on there. So be aware of others, be friendly, and be patient. So this is a learning environment for everybody to learn and sort of gather around, ask the great questions, be respectful, and just have fun. That's what it is. So the chat is open. So if you are on if you're watching this through LinkedIn, I will periodically put in the same links that I'll be putting into the main chat. Again, ask questions. We will see them through StreamYard. And of course, if you're watching on YouTube, please do pop your questions into the chat. It's open. We'll try and answer them as quickly as we can. And if you're watching via my Twitter, then, well, tag me in some comments, tag me, tag Carlotta, let's get with it. And yeah, post your questions. So, what are we going to be talking about today? So on the agenda, we have got only a couple of items because we want to make this as hands-on, as fun as possible for you. So the first thing I want to talk about is a cloud skills challenge. The second thing we're going to talk about is natural language processing, or abbreviated NLP. Third is text classification. And of course, at the end, we have got a nice demo. Now, I'm also going to try and do a demo during the middle of that, which was kind of added in last minute, but I think it's pretty relevant to what everybody's talking about. So let's jump into it, shall we? So as always, we always have learning goals. And of course, there's always 2. So today's learning goals is to understand what natural language processing and text classification actually is at a high level. And secondly, to learn how to build text classification models with ML.NET. Okay, so 2 different concepts, 2 different learning goals, and hopefully you'll have some fun and understand it. So, of course, we have a Cloud Skills Challenge. What is it? Well, a Cloud Skills Challenge is a collection of Microsoft Learn modules. Of course, this is all free for everybody, so please do go ahead and get stuck in. If you go to aka.ms/ML.NET series, you'll come to a page which has a number of links on it. You'll have a Cloud Skills Challenge. You will have the Microsoft Reactor YouTube channel and the Microsoft Reactor meetup group. If you have joined via any of those, or if you're not part of them, please do go and check it out. All of our live streams are done through the Reactor YouTube channel, and most or all of our events are posted through the Microsoft Meetup community board as well. If you scan the QR code, you'll go directly to the Cloud Skills Challenge, and we cover everything around it to help you on your learning journey of understanding and getting stuck in with ML.NET. Now, the best part of this is it's not just yourself that's learning this. For those of you who've seen me on the Reactor YouTube channel before, or running in-person events, then you'll know that I also don't know .NET or do anything with AI and ML. So I am learning along with you too. And that is why we have the fabulous Carlotta here to help teach us all together. So everything I do or everything Carlotta does, you can do it too. It's all free. you can have a little play, you can get hands-on with it. And of course, if you want to sign up for an Azure student account, or if you're a student, go to aka.ms/A4S, or if you're not a student, basically anybody else, go to azure.microsoft.com/free. There you can sign up for a free Azure trial account. You'll get $200 of credit, which you can use over a month, and you get access to a whole bunch of cool services, some of which we're going to be using throughout this series. So what prerequisites do we need? Well, as we went through last week, you just need Visual Studio. You need .NET and the Model Builder extension to go with it. Now, the Model Builder extension has a caveat. You have to use Windows to use it. But if you're like me and you're using a MacBook, then you still have the option to do this. You can use it through a virtual machine, or you can use it via dual booting your MacBook. And there are other services online, of course, if you are not using Azure, that you can get this through as well. So there's always routes there. Where there's a will, there's a way. Okay, so stick with us, enjoy, and have some fun. So, like I said, this is episode number 2. We're going to be talking about text classification with Model Builder. And of course, if you didn't catch up last week, we talked about getting started. We talked about what ML or what machine learning is, what .NET is, and of course, a combination of what ML.NET actually is to help us with today's stream of building and deploying a model. And of course, next week, we are going to be consuming and deploying more ML models. So we're smack bang in the middle. This is the best place to be right now. So come on and let's learn together. So what is natural language processing? Well, NLP is basically an enablement of AI, right? It helps process and interpret data that you give to it, and it gives you then an output, whether that is human readable or not. It gives you, it's an input-output model, okay? And it's all to do with written text. Now, we use this pretty much every day without even realizing it, okay? So if you think about some of the projects or some of the sort of services that you use, maybe Siri, maybe Cortana, maybe, I don't know, Google Home, Amazon Alexa, Google Maps, any of these cool services, it uses a lot of NLP, a lot of AI, a lot of different technologies under the cover without you realizing. So let's go for a brief history. Let's have a little look. So in 1966, Eliza came about, and that was a typewritten chatbot, okay? Now, we may think of that as, you know, in 1966, what kind of computers were about then? I think maybe the punch cards that you had. I think IBM were sort of churning those out at the time, punch card coding. That was pretty cool. But how do we look at what a NLP looked like back then? Well, if you Google Eliza and have a little read up on it, you will see exactly that, okay? In the 1980s and the 1990s, that decade, right? There was a big gap. Okay, so there's about 20 odd years there. What happened in the meantime? Well, I guess they kind of figured that technology wasn't as advanced as maybe they needed it to be at that time. Super niche area to be working in, right? You must agree. And this is when the research continued and carried on through, because technology had advanced to a certain point now. It is actually usable and people are able to get hands-on with it in a more sort of structured fashion. So this is when they started making new statistical models. Okay, so if you think about a neural network and how that may diagram out, and I'm sure Carlos is going to explain this and go through this shortly, kind of that idea, but back in the 80s and 90s. Now, again, technology was still, it was okay. It was getting better. I mean, it was booming, of course, but it was by no means, obviously, anywhere close to where we are today. And again, there was another bit of a break. You know, I think they realized you couldn't quite do it all. So it kind of just faded out a little bit. In comes 2010. Here comes the 2010s. And this is when it really took off. This is when everything went, you know, through the roof as far as we're concerned with technology, NLP, AI, that whole movement to cloud was in the 10s or the 2010s, right? So this is when you had Siri, Cortana, Google Assistant, Amazon Alexa, Home, all these kind of things started popping up. And if you're a bit of an Apple geek like me, and I probably shouldn't say that, I think Siri came out in October 2011. I'm sure somebody on stream can Google that or can correct me if I'm wrong, but it came around that sort of time. Now you can see how early on and how long ago it was, considering we're in 2022 now, almost in 2023. So that's like a good 10 years of sort of technological advancements just within Siri. And Siri is when, I don't want to say it because I've got my phone next to me. But if you start saying certain command words, then you're able to talk to it and have a conversation, ask it questions, ask for directions, restaurants, all those kind of things, right? So you can kind of see where we came from. And this is all natural language processing. The same as if you say, hey, Alexa. And I also hope no one's played that out loud around Alexa, because I'm sure that would have kicked it off. But then we look at today. We're in 2022, right? Another 5 years on from the likes of, the boom of home assistants and smart assistants and services, right? And of course, if you're looking online right now on Twitter or, I don't know, Matrodon or any of those, you're going to see a lot of people talking about OpenAI GPT-3. And we're absolutely no different here. And this is going to be the fun part, or the fun part of my part of this stream today, because I'm going to show you a little something with this live, and I hope it really works. But we have come in such incredible speed that I had a bit of an email. I had an email come through last week, and I was totally unsure of how to respond. And then I saw this thing like kicking off on Twitter, and I was like, you know what, I'm going to give it a go. And it wrote the absolute most amazing, comprehensive reply that would never have come out of my mind ever. But it was the best. And it was all thanks to me just pasting in this email and say, give me a reply. Give me something to give back to it. And all I did there was give an input to get an output. And that, on the face of it, at a really high level, is technically what we're doing. But with every input that you give to one of these models, it's learning, it's training it, it's getting better, it's iterating over and over and over again. So if you think about all the data it collects, it's only going to get exponentially better for everybody else that then uses it. Okay, so imagine where we are now, 2022. I can't picture where we're going to be in 2030, 8 years time, or 7 years if you sort of count where we are. So I'm going to jump out of this and I'm going to see if I can get it to write me a poem about cars. So I signed up, I had a little play with OpenAI GPT-3, and I'm going to see if we can get something going live on stream. And it'll be absolute sod's law if it doesn't, but we're going to give it a go nonetheless. So obviously, if you go in, you open it up, you get like a whole bunch of these prompts, some introductions, some basic sort of playings. And what I'm going to do is I went into the playground and I just said, write a poem about cars, full stop. Okay. And I'm going to click submit, and hopefully there we go. All right. It's kicking off straight away. Now, hopefully this gives something fun and nothing not safe or controversial. But it says, hey, cars are symbolic of freedom and joy, a way to get around without any annoy. They come in all colors, shapes, and sizes, and can take us great distances. I don't know how this works. This is a poem, basically. I'm not going to say any more, but you can see how cool this really is. Okay, I just recommend, hey, giving this a go, having a little play with it, and trying it out for yourself. So with that, I'm now going to hand over to Carlotta, who is going to be taking us through the rest of the presentation and the little demo for what we really wanted to do. This was the last minute thing that I just wanted to throw in here and talk to you all about and show you, because, hey, it's fun and why not? So Carlotta, I'm going to ping this one over to you. Let's remove my my screen and let's throw your one up.
Yeah. Thank you so much. Thank you so much, Liam, for this great introduction. I'm sure now we all have a general understanding of what natural language processing is and in what kind of scenarios we use them every day. And you are really you're right. The kind of technology we have today is incredible. So in some specific applications, technology, AI really has capabilities very, very similar to humans. So it's something very fascinating for me and for everyone, I think. But let's see a little bit, let's reveal a little bit what's behind the hood of all what we said so far. And in particular, let's focus on one application of natural language processing, which is text classification, because we are going to do a brief demo around doing text classification in ML.NET. Text classification has been enabled in ML.NET recently, in particular the UI part, so the possibility of applying text classification with model builder, so using graphical user interface has been announced a few days ago. So I'm really pleased to show you how it works in this brief demo. But before that, let me just explain a little bit in general what's classification. So classification is a supervised machine learning technique in which you train a model using data that includes both the features and the known value for the label. And you want to get as output a category, a class, the input item belongs to. For example, given as input an email, an inbox email, a classification model is able to categorize it as spam or not spam, starting from some features like the length of characters of the email body, the sender address, or the timestamp of arrival of the email. And this is called binary classification because we have two types of categories, spam or not spam. While if we want our model to be able to classify the inbox email with multiple categories, like business, family, love, this is possible as well. And this is called a multi-class classification because we have more than one category as possible outputs. Great. Now, there are lots of algorithms to perform classification. As I said also in the first episode, machine learning is huge, is a huge thing. And I would like here to do a distinction between the ones that belong to the family of classical machine learning algorithms and the ones that are placed under the umbrella of deep learning. So deep learning includes the statistical models that Liam mentioned a few minutes ago, called neural networks. So classical machine learning algorithms basically work on numerical or categorical features. Like in my previous example, features like the sender address type, the timestamp, the length of the characters of the email body. Also, they work well on relatively small data set, and they are usually lightweight and interpretable models, easy and fast to train. When I say interpretable, for example, here you can see a tree-based model, which is one of the probably easiest one to interpret for a human because it has this tree-based structure. And in each node, we have a splitting decision. And based on this decision, which is an if-then else type of statement, we go left or right in the following node. And this is done from the top, from the root of the tree, until the leaf in which we have the output predictions, so the labels. On the other hand, deep learning algorithms work well on large and unstructured data set. When I say unstructured data set, I think about multimedia type of data, text, images, video. These algorithms are large black box models because they are not easy to interpret at all. And they are known as neural networks since the way they work is inspired by biology and in particular by the mechanism the neurons of human brain work to transmit information from a neuron to another. And they need huge compute resources for training, and training is time consuming. So of course, these look like a series of disadvantages, but the big advantage of using deep learning, of course, is the performance you can get and the capabilities you can achieve. For example, the OpenAI GPT-3 model that Liam just showcased is based on deep learning. And also the model we're going to use for our demo today, it's based on deep learning. So in this family of neural networks, one of the most common and most performant models right now for text classification is called transformer architecture. Both OpenAI GPT-3 and the model we're going to use today, which is called BERT, is based on the transformer architecture, which is an architecture consisting of encoding and decoding layers. The encoder takes raw text as input and maps the output to a numerical representation of the input, including the context on which the sentence is placed in the text, to produce features, while the decoder uses information from the encoder to produce an output, such as a category or a label in the case of text classification. Now, what makes this layer so special is the concept of attention. Attention is the idea of focusing on specific parts of an input based on the importance of their context in relation to other inputs in a sequence. Let's do an example. Let's say I'm categorizing inbox emails based on their subject. Now, not all words in the subject are relevant, of course. Not all word has the same weight. In a subject like come and discover the promotions reserved for you, for example, a word like promotion might get more attention and lead to labeling the email as advertisement. Like most neural networks, training transformers from scratch can be expensive because they require large amounts of data, as we said, and also large compute resources. However, you don't always have to train this kind of models from scratch. You can use a technique which is known as fine-tuning, in which you can take a pre-trained model and load it in your machine learning context and retrain the layer specific to your domain and your problem using your own data. And this gives you the benefit of having a model that's more tailored to solve your problem without having to go through the process of training the entire model from scratch that would require a lot of data that in some cases you don't have. And this is exactly what happens with the ML.NET framework, where you can build a text classification model for your specific use case by specifying and customizing the model on a specific dataset and fine-tuning a pre-trained torch-up implementation by Microsoft Research of the NAS-BERT model. Now, without going into too many technical details, TorchSharp is a .NET library containing the building blocks for training neural networks from scratch in .NET ecosystem, while the NAS-BERT is a variant of BERT obtained with neural architecture search. And you can choose to customize this model on your dataset with two different approaches. You can use a UI on Visual Studio, which is called a Model Builder. We had a look to Model Builder also in the first episode. This allows to add a machine learning configuration to a .NET application with a low-code approach. Or you can directly invoke the text classification APIs upon which the model builder is based and write some C# code to train, evaluate the model, and make predictions. In both cases, after training the customized model, you can also evaluate its performances on a subset of your data. In our demo today, we are going to combine both approaches. We will get started by creating the model using the Visual Studio UI for machine learning, so the model builder, and then we'll modify the auto-generated code by model builder to improve the final model performances. And finally, we'll integrate it into a console app that consumes the model by asking the input text to the user through the console. So let's go to the details of this demo I will be showing today. So in a virtual world where there are thousands of sources of information across the web, bots posting on social media, on Twitter, on Facebook, and artificial intelligence generating fake news, it's hard to identify if a news or a tweet or a post on a social media is true or not. And for our demo, we chose a dataset collecting a few thousands of tweets published by a controversial celebrity, who is Elon Musk, throughout 2022. And since we didn't have the information if the collected tweets were actually written by Elon Musk or were fake tweets written, for example, by a bot or a hacker, we randomly labeled them as fake or authentic just for the purpose of our experiment. So our use case scenario is training a text classification model in ML.NET, which is able to apply a binary classification to a tweet as input to tell us if it's fake or authentic. And to do that, let me jump directly on Visual Studio. And in particular, let me open the model builder page. So as mentioned before, we'll be starting to build the model using a low-code approach. And last time, in the first episode, we only had a first look to the guided steps you need here to build and evaluate a model with Model Builder, and we had a look at the possible scenarios, machine learning scenarios available in Model Builder. For our demo today, we are going to choose the text classification scenario here, and then as environment, we're going to choose the local CPU compute resource to execute the training operation. However, I need to say here that the recommended compute resource to execute the training operation is not CPU for deep learning type of scenarios, but it's GPU to optimize time spent on training. So if you have a CUDA compatible GPU on your local machine, choose the GPU option. If, as like me, you don't have a local CPU, a local GPU, NVIDIA GPU option available on your local machine, you can still rely on the CPU option. Now, next step is uploading the dataset. Our input file, the tweets from Elon Musk I mentioned before, is a sysvoo type of file that we upload from a local source, a local folder. Once the file is loaded, we need to specify the column we'll be going to use from prediction, which is called label, and the column we'll be using to infer the label by applying text classification, which is called the text column. The label of our dataset is named isFake, and it is 1 if the tweet is fake and 0 if the tweet is authentic, while the text column is called clean tweets because they include the content of the tweet clean from any mention or special character to make the training more effective. Great, so this is the data step. You can also see a data preview if you want to. And then the next step is the core of our process, which is the training. Let's recall here that we are not training a deep learning model from scratch. Okay, it's not our objective and our goal. Our dataset contains little more than 2,000 rows, so it would be impossible to train a deep learning model with such a little dataset. What we are going to do is just taking the torch-sharp implementation available in ML.NET of the NASBERT and fine-tuning this model by customizing it on our scenario and our dataset. By the way, since I'm using a local CPU type of resource, as I said, the training needs a few minutes to complete. So I already executed the training procedure beforehand to not waste time on the streaming. And as you can see, here, I already have the output, have the training completed. And as output, what I got was the time spent for training and the name of the best model. In this case, the name of the best model is the only model trained for this experimentation, because for this specific scenario we have only one model. But for other type of scenarios in ML.NET and Model Builder, like data classification, for example, Model Builder tries more than one model and then output the one with best performance. And that's why you see best model here. Also, you can see that 2 CS files have been created containing the auto-generated C# code to retrain the model and also to consume it in a .NET application. In addition to that, you also have as output the accuracy of the resulting model, which is 0.63 in this case. So accuracy is defined, is probably the most common evaluation metric for classification, and is defined as the ratio of number of correct predictions to the total number of input samples. And in particular, the microaccuracy aggregates the contributions of all classes to compute the average matrix. And the closer to 1, the better. Finally, the last step is, before consuming the model, is the evaluate step, where you can try your model by entering a tweet and asking for predictions. And what you get is the output category with the probability of this is the score, the probability score of this tweet of belong to the category true. So of being fake in this case. But let me show you, let's have a look to the auto-generated code, because it's very interesting to have a look to the auto-generated code for more advanced scenarios in which you don't want just to create the model, because at this moment we have already trained our model just using a few clicks, so just using the graphical user interface and uploading our dataset. We got our model, we can use it for prediction, so we could be in the final step. But for more advanced scenario, we could have the need to customize a little bit the auto-generated code. For example, because we are not satisfied from the performance we get initially, and we want to improve the model performance, or we want, for example, to upload new data, or we want to integrate this model in another app. So let's start by looking at the text classifier.training file. Here you can see at the top of the file a declaration of the text classification with model builder. Sorry, the text classifier class defined as partial class. Why? Because a portion of the method of this class are defined here in this file, while the remaining ones are defined in the other CS file. And in particular, the methods that we see defined here are the ones related to the retraining of the pipeline. So they are the ones needed to relaunch the training process. For example, as I said, to do further fine-tuning or to update the dataset with further data. And the retrain pipeline function wants as input the machine learning context and the training data. The machine learning context is the common context for all ML.NET operations. And once instantiated, it provides a way to create components to perform different tasks, from data preparation to training or feature engineering. And the main steps here to retrain the model are building a new pipeline, where a training pipeline is no more than a definition of the steps to perform to train the model. So the data preparation, the data preprocessing, the training with a specific trainer, and some post-processing of the data if needed. And in our specific case, if we look at the pipeline is built with three components. We have a map value to key function here, a map value to key conversion, to prepare the data for training. Then we apply the actual text classification, specifying the label column and the text column, what we did in the UI with the drop-down menu. And then we have, again, another conversion, this time from key to value. This is basically written in code, what we have seen in the deck beforehand, with the encoder and the decoder components of the transformer architecture. And most of the machine learning algorithms work well with categorical type of data, which means by mapping label with numbers. And that's why we need this conversion here. Great, so this is our pipeline, and then we just feed the pipeline to our dataset to actually launch the training process. Let's now look at the consumption auto-generated file. Here we have the methods used to consume the model, so to make predictions on unlabeled unknown data. We can see here that we have the MLNet model path, which is basically the file to the zip, the path to the zip file in which we have saved the train model, or better, not we, but the model builder saved the train model. So we retrieve, we can retrieve the path of the zip file here. And then a predict engine is defined to integrate the model into the console app. And this predict engine is defined with the create predict engine function, which is defined below. So the create predict engine basically instantiates the class engine for prediction by loading the model from the zip file using the path we just retrieved, and then define the expected input and output of the model. These model input and model output are two classes that you can see here, and these classes basically shapes the format of the input of the model and the output of the model. So the kind of object the model expect as input and output. Great, so this is the auto-generated code. But now what I want to show you is a quick look on how you can modify this auto-generated code to retrain the model and to consume it by asking for input text to the user through the console, for example. So let me jump on another project in which I did some edits I want to show you. And this time, so this is a similar console app to the other one, but in this case, I applied some edits that I will show you on the auto-generated code. Let's do like that to maybe, yeah, in a way that you can see better the code, since this code is more, there's more code here. And let's start from the program file this time that we didn't see for the other console app, because the auto-generated program file from Model Builder is just an hello world type of file. While in this case, the program file, which was not auto-generated, but it was written by me, is the startup of the app itself. And what we can see here is that this program is asking as first question through the console to the user if they wish to retrain the model or not. And if yes, the model is retrained with a slightly different pipeline with respect to the one we saw before. And this new pipeline includes two hyperparameters, which are parameters used to fine-tuning, further fine-tuning and improving the model performances, or trying at least to get improvements on the model performances, which are called batch size and max epoch. So these parameters basically tells to the training engine to how many iterations and how many batch of samples it should use during a training process. But we will see these in a few. Before going into the details of pipeline retraining, let me show you the rest of the program code here, which is quite simple. It's just, you can see it's just a loop here, where we ask for an input text from the user to make predictions until the user type the word "and" if they want to just end the program. While the input of the user, if it's different from "and", is used for the prediction. So it's used as input to the model. And the output that the user gets on the console is basically one of those two strings. If the prediction is 1, so is fake is equal to 1, we get the string "this tweet is fake." Otherwise, we get the string "this tweet is authentic." So let me run this quickly to show you how it works. So as said, the first the first question is if we want to retrain the model. For now, since it takes some minutes, let's say no. I want to show you how to consume the model first. So, for example, let's insert a fake tweet here, like I'm Elon Musk. And I should get, I should get as answer, this tweet is fake. Now let me paste another tweet, which is a real tweet now. For example, the people of Twitter strongly agree that Twitter needs to be fixed. This is a tweet which Elon Musk really actually posted on Twitter. And the answer is this tweet is authentic. And to end the program, we just type end. Let's run again the program because I want to show you the retraining part now. So this time I will choose yes to retrain the model. And you can see that it is telling me that it is splitting the dataset into two subsets, one for training and one for testing. And it is retraining the pipeline with the hyperparameters. And in particular, it is using 32 as batch size and 5 as number of epochs. But let's see the code here while it runs, because it will last a few minutes for the training. So let me show you the training part here. So to retrain with hyperparameters the model, what I did actually was create again a machine learning context here, then loading the data again that I want to use for training, which are the same I uploaded in the UI, in the model builder UI. And again, I specified as a label column the isFake column. And then what I did was splitting the dataset into two subsets, one used for training, the 80% of the data, and the rest used for testing, the 20% of the data. And then I used the text classification API to retrain the pipeline, so relaunch the training with, as I said, a slightly different pipeline, because this time what I did was to add the batch size and the max epochs. So if we go inside this function, which called the build pipeline, you can see here that I edited the pipeline in a way to pass the batch size and the max epochs here to try to get an improvement in the performance of the model. So this is just an example of how you can use the auto-generated code from Model Builder to do some more experiments and improve and get improvements in your experiments, in your model. And then the last phase is the evaluation phase, in which we use the model trained, the new retrained model to on the test dataset, and then we evaluate the result by with the micro accuracy again, by computing the differences between the predicted and the actual value, and we print on the console the micro accuracy result. So I don't know if it is finished. No, the training is not finished yet. So probably what can I do is just pause for 1 minute if there is any questions so far, or Liam, if you have any comments.
Yeah, I'll tell you what, I do have a few. So we don't actually have any in the chat. So if you are watching, please do throw some questions in the chat. This is all so much to take in, but it's a really, really cool lesson to be understanding how these are built from the bottom up, right? So I have a question for you, Carter. So Model Builder automatically spits out this code presumably with all of this comments as well, which is really, really helpful. Is it only just in C#, or is there other languages that you can train models in, like Python? Is that an option?
No, so basically, the ML.NET is designed for developers familiar with the classic languages of the .NET ecosystem. So C# and F#.
F#. What about VSB? Is that one?
Yeah, but Visual Basic is not a language which is commonly used for data science. So the option in ML.NET you have are around C# and F#. So the text classification API actually works also in F#, or in general, the APIs for ML.NET work also in F#. But the difference between other machine learning frameworks, between ML.NET and other machine learning frameworks, is really that you can do machine learning with languages that are not the common ones for machine learning. So people which are more software developers, which are more familiar with C#, for example, or in general object-oriented type of languages, are probably more comfortable with C# rather than R or Python.
Brilliant.
And so, this is really to democratize machine learning to other roles, other kind of people who are not like the so-called data scientists.
Yeah, lovely.
But of course, also data scientists can use ML.NET if they want to experiment with other languages and other frameworks.
Amazing. So this is kind of in its own little silo to kind of go up against different ones like PyTorch for Python and that sort of thing, right?
Yeah, right.
Wonderful, amazing. Right. Thank you for explaining that. Thanks for going through that. I think as far as questions go, the chat's pretty empty, but it's really cool to see how little code you need to run something like this. So that's a really nice example that you showed there with the tweets. I really like that one. I mean, we're not tech bashing at all. It's just a really good way to determine. I mean, there's a number of people which you can choose for false and accurate tweets, right? So we went for the most obvious one, being Elon there. But it's a brilliant explanation to kind of demonstrate this. And how does it do that exactly? Does it scan the data? Does it sanitize the data from all the tweets that Elon has tweeted, and then sort of takes in, his language, his persona, who he is, and like build a character for him? Is that what it's doing under the hood?
So actually, this is a quite easy simplified example in which I really just collected. Actually, I used an open data set available on Kaggle. Nice. That I refer also in the GitHub repo. I will redirect people in a few with the link to the GitHub repo. And I just labeled this data set with randomly is fake and not is fake, because I didn't have the information about the real information if the tweet was fake or not. And so basically what the model is doing under the hood is working with the text column, which was the clean tweet column. But the pre-processing to clean the tweet is not done by the model itself. It should be done beforehand. In fact, and this is valid in general, it's very important to do pre-processing on the data set before using this data as input to the model. I would say that data pre-processing is half of the work when you do data science, and the other half is training.
Okay. Nice. So it's got to be clean data before you put it in, right, to avoid any anomalies and whatnot when it comes out with the output. That's correct?
Yeah, that's correct. So and again, this was like a simplified example. So I had already the clean tweet, but in real life scenario, you probably need to clean yourself the tweet, or maybe select them in a more careful way.
Okay, fantastic. Thank you. Thanks for sort of explaining that, because like everybody else on the stream, I'm also here learning, hence the questions, right? And that being said, we do have one question that has just popped in, Carter. So I can see that your program is ready to go, but we'll quickly ask this one. Robert has asked, how does the encoder work in this model? I.e., how do you go from a string of text to a numeric input for the model?
So what the encoding does in this case is actually converting the text into a categorical type of value, because deep learning algorithms also other machine learning algorithms, but deep learning algorithms in particular, work well with categorical type of variables. So we need to convert the values into numbers, because models work better with numbers. Yeah.
Amazing. Cool. Well, thank you. I'm going to let you carry on, because we've only got a couple minutes left, and we still have a few slides that I want to go through prior to ending the stream. So I'll crack on.
Sure. Just a quick comment on the result here. So the retrained model microaccuracy is 0.65. If you remember, the initial accuracy we got just with the model builder was around 0.63. You could argue that it's not like a very great improvement, but machine learning is a process of a lots of experiments and a lots of time-consuming also actions before getting improvements, and also these little improvements might need a lot of work behind the hoods, and in particular, usually getting the first result like 0.63 is very easy, while improving little by little, in particular if you don't do a bigger modification on your data set, is the hardest part actually. So this was just a brief comment on the result. But feel free to go back to the decks, Liam, if we need to wrap up now.
Amazing. Thank you very much. Just before we sort of crack into this one, you said it was 0.6, right? So presumably, is this the number between 0 and 1 as maybe that full scale? Is that how it's
exactly
determined? Okay, brilliant.
Yeah, for accuracy, the scale is between 0 and 1, exactly.
Lovely. Okay, cool. So I learned something new today. Like I said, I'm learning all of this along with everybody else. So it's absolutely fantastic to have Carlotta. So an absolute massive thank you for that demo. That was brilliant and really well explained. Love the code, love the example, and I love the way that you're going about it. So for everybody else on the stream, again, we have a Cloud Skills Challenge. So scan this QR code, you'll go straight to the challenge, or alternatively, go to aka.ms/ML.net series. That will take you to a big page with lots of different links that you can join us on, and you can sort of sign up to our different social medias and understand, what it is that we do, what we're trying to achieve here, and build a community with. Also on the right-hand side, we have got the demo that Carlotta has kindly put together. She's put together a repository. So if you go to aka.ms/getting practical with ml.net GitHub repo. That's a bit of a long one, but what we'll do is we'll pop that one in the chat. So if you want to pop that one in the chat for us, Carlotta, that'd be amazing. As well as the Cloud Skills Challenge, aka.ms/ml.net series. That would be brilliant. And that will go to everybody in the chat. What's next then, everybody? Sorry, were you going to say something, Carlotta?
Yeah, just a short comment on the GitHub repo. I wanted to share that in the next episode we will be showing how to use this model into a web application. So this repo will be updated with the code we'll be showing next week.
Amazing. Thank you. Yes, that will be. Oh my goodness, the third episode is next week already, isn't it? Talking about that, what is next? So on the 15th of December at 6 p.m. GMT, so that is local time UK, we're going to be running through the final episode of the series. Now, there's a short caveat to that. I'm going to be in a completely different country. I'm going to be in Israel. But we're going to have, I'm still going to be on the stream, I'm still going to be here, and I'm still going to be presenting with Carlotta, and we have got a great episode lined up for you there. So at a little bit later, 6 p.m. GMT, not the standard 4:30 that it has been for the past 2 weeks. So we hope to see you there. An absolutely massive thank you for everybody who has joined, who has stuck around and watching on the different channels. It's great to have you here. It all makes this worthwhile. And of course, we're trying to build such a great community here at Microsoft Reactor. Now, I have to scoot. We are actually bang on time. I need to go upstairs and present in person to the Christmas party, hence the lovely Christmas jumper that I am wearing today. So if you're watching this upstairs, I'll be up in a second. And of course, if you are going to be watching that online, please stick around. We're going to be going live in about another 15 minutes. We'll be hitting up the next live YouTube or YouTube link. So keep an eye on our channel. Amazing. So thank you very so much, everybody, and goodbye for now.
Thank you. Bye-bye.